So in this video, I'm going to go through page 1 of the Unit 4 study guide. Part 1, or page 1, starts talking about the closure property. And it starts off with two polynomials. We've got f of x here, which is 3x squared minus 2x plus 4. And we have h of x, which is 2x plus 5. And we're told for parts A, which is addition, part B, which is subtraction, and part C, which is multiplication, we're supposed to use these two polynomials to show how the sets are closed for each of these. Then for part D, we're supposed to explain why the set is open or not closed for division. So first thing I'm going to do with part A, which is the addition piece, is I'm going to add f of x and h of x. So f of x is our nice little polynomial here. It's got 3 terms to it. And I'm going to add h of x, which is a 2-term polynomial. Okay. And remember, with polynomials, when you're adding or subtracting, you just want to look to combine like terms. So 3x squared has nothing else like to it, so 3x squared. Let's see, negative 2x would be like to positive 2x, but when I combine those by adding, there's not going to be anything there. Then separately, I've got positive 4 here plus positive 5, so that would get me plus 9. Now, it doesn't matter how many terms I create here. What matters is that I added a polynomial to another polynomial, and what I've created is a polynomial. So I'm actually going to use the text feature to write a quick sentence here. It's probably going to be really small, so let me increase my font size here just a little bit. Okay, whoa, that was really big. Hold on a second. I didn't realize it was going to be that big. Okay, when I added 2 polynomials, I created a polynomial. Therefore, the set of polynomials is closed under addition. So when we say that a set is closed, it means that when I add any polynomials together, I will always create something that is considered a polynomial. It doesn't, again, matter how many terms it has. It doesn't matter. As long as you take 2 polynomials and add them, you will always create a polynomial. All right, I'm going to do the same thing for subtraction. All right, start with my 2 functions here, 3x squared minus 2x plus 4. But this time I'm going to subtract, so be careful with subtraction, 2x plus 5. Now, if it helps, you may want to distribute the negative sign. In fact, that's what I'm going to do. So this first polynomial, nothing's going to change. But this negative, I'm going to multiply times 2x, and I'm going to take that negative and multiply it times 5. So negative 2x minus 5. Now I'm going to go hunt through and look for some like terms. 3x squared has nothing like to it, so I'm going to leave it as 3x squared. But now I've got negative 2x minus 2x. Those do not cancel. They become negative 4x. And I've got positive 4 minus 5. If I combine those 2 constants, I'm going to get negative 1. Now, it's nice that I got a 3-term polynomial here, but it doesn't matter how many terms. What matters is when you subtract polynomials, you are going to create a polynomial. So that's the part that it's important for the closure property. So the idea here would be, when I subtract 2 polynomials, I will always create another polynomial. Therefore, the set of polynomials is closed for subtraction. Okay. So again, whenever you subtract, hold on one second, since clearly that just moved places I didn't want it to go. So whenever you subtract two polynomials, you will always create another polynomial. And even if all the variables cancel out, constants are considered polynomials. They're a type of polynomial, and that's okay. So you can have all the x's disappear and just be left with the number 5. That's okay. 5's a polynomial. It still works. For part C, we've got multiplication. So I want to multiply my two polynomials together. So 3x squared minus 2x plus 4. But this time I'm going to multiply it times 2x plus 5. Now, however you like to do multiplication, do multiplication. I tend to use distributive property. So I'm going to take this 2x and multiply it times those three pieces. So 6x cubed minus 4x squared plus 8x. And then separately, I'm going to do the exact same. I'm going to slide this down just a touch. There we go. Separately, I'm going to do the exact same thing with this positive 5. So multiply here, here, and here. All right, so plus 15x squared minus 10x plus 20. Let me do a little combining of like terms. So 6x cubed plus 11x squared minus 2x and then plus 20. Now, I've said it a bunch of times already in this video. It does not matter how many terms you end up with here. You're going to create a polynomial. So in all the times that we've been doing multiplication or distributive property, you've always created something that's a polynomial. So that's why this set is considered closed. All right, when multiplying two polynomials, you will always create another polynomial. So, whoops, yeah, there we go. So the set of polynomials is closed for multiplication. All right. So yeah, it won't matter. We've always done multiplication with polynomials and created more polynomials. Okay. So now the new part is part D here, where we talk about doing possibly some division. Now, the order that you divide matters. And so to make my life, I'm kind of lazy. So to make my life easier, I'm actually going to purposely create a division problem that I can't do. So I'm going to take that 2x plus 5 and I'm going to divide it by 3x squared minus 2x plus 4. I can't do anything with this. It's just not possible. So now I've created this situation where I've created a division problem, polynomial in the numerator, polynomial in the denominator, but this answer is not a polynomial. 2x divided by 3x squared, if we were to try to do synthetic division or long division, well, it's not going to work. So because of this, it's very easy to see that we are not creating something that is a polynomial. So quick explanation here. When you divide two polynomials, you do not always create a polynomial. Therefore, the set of polynomials is not closed for division. Okay. It doesn't mean that the answers don't exist. All right. It just means that you don't always create a polynomial. Okay, that's the idea behind closure. If a system is closed, then whatever system you're working in will only create those values. So addition of polynomials is a closed system. So if you're working with polynomials and you're adding them, you'll always be working with polynomials. So division just doesn't have that same thing, so we say it's not closed. All right, so that's enough of the closure property for right now. Problem number 2 says to use the factor theorem to determine the unknown coefficient in the function. Now there's 2 examples here. The first example I'm going to do with the function notation, and the second one I'll do with synthetic division, just so you can see both. You pick which one you like better. All right, so for part A here, we know that we've got x minus 7, so I'm going to find it 0, which means x is equal to 7. And what I want to do now is basically find g of 7. So every place I have an x, every place I have an x, I'm going to replace it with a 7. Minus 8 times 7 minus 42. Now, because x minus 7 is in fact a factor, that when I put this function value in, all of these 7's replace x, and the function is then equal to 0. All right, so I'm going to go ahead and I believe I'm going to try to pop open Desmos here, because this is a great place to use a calculator. All right, so let's see, 7 to the 4th is equal to 2,401. Negative 4 times 7 to the 3rd is negative 1372. Now 7 squared is, I'm saying just, but it's 49. I can do that one in my head. 49a minus, let's see, that should be 56 minus 42. So what I'm going to do is I'm going to grab all of these constants here, the 2401, negative 1372, minus 56, and minus 42. Combine those all together. So 240.01 minus 1372, whoops, lost a 7 there, 72 minus 56 minus 42. All right, so I'm getting 931 plus 49a. So I'm going to subtract 931 from both sides. Let's see, negative 931 is equal to 49a. Divide both sides by 49. So let's see, what is negative 931 divided by 49. So a is equal to negative 19. All right, so that's how you do that if you have, if you want to use the function notation. I'm going to go ahead and do part B with synthetic division, and that will be then the last problem that's on this page or this video. So first thing, I'm still going to take my factor, set it equal to 0. Okay, so that's negative 3. And I'm going to use that negative 3 with all of the coefficients to, whoops, that does not look like the same value there. So let's try that again. There we go. Okay, so coefficient of x cubed, x squared, coefficient of x is c, which is weird, but that's okay. That's what we want. And then the constant's 15. All right, a little bit of workspace here. Drop my first value. That's going to be 1. Negative 3 times 1 is negative 3. Let's see, add straight down. 6. Negative 3 times 6 is negative 18. Add straight down, so c minus 18. Now I'm still going to take that value and multiply it times negative 3. So negative 3c, and then let's see, what's negative 3 times negative, times negative 18. So that's 54. So plus 54. And I'm going to add straight down. So negative 3c, let's see, 54 plus 15 is 69, so plus 69. Now, because I know that x plus 3 was a factor, I know that this remainder absolutely has to be equal to 0. So that's actually what I'm going to solve, is I'm just going to set this remainder equal to 0. There we go. Spell the word remainder right. All right, negative 3c plus 69 is equal to 0. So I'm going to subtract 69 from both sides. So negative 3c is equal to negative 69. Take that negative 69 and divide it by negative 3, and you're going to get c is equal to 23. All right, so that's page 1 of the study guide dealing with a little bit of factor theorem and the closure property. Let me know if you have any questions or concerns.